Howdy folks, Chris the Carpenter here with Let'sMakeRobots.com doing a review of the Daegu Wild Thumper motor driver. And here it is. Here is the motor driver in question, sitting on top of Walter the robot. Now, let me just go through some specs here. Dual 15 amp FET bridges, current sensing on both sides, inline onboard fuses that can be, if they're blown, can be detected by the controller, as well as a indicator light. The whole controller is has an onboard Atmega 168 already bootloaded with it's speaking Arduino out of the box. But I mean, it's an Atmega. I mean, you can make it speak whatever you want it to speak. Has ISP 3x2 ISP plugs for programmers, if you like. You've got 7 digital I/O pins left over after the motor controller uses the pins it needs. Has 5 analog inputs, 5 amp low dropout regulator, 5 volt regulator on board to run your peripherals. There's a 2 amp charging circuit on board for your NiCads, your metal halides, your sealed lead acids, etc. Not the lipos. It is already wired to monitor your battery voltage. It can talk to your host. It can be its own host. It can be its own robot brain. You can also talk to your robot brain using all the regular ones, USB to the computer, regular old TTL UART serial, I2C, and then out of the box it actually speaks RC remote control. It can actually do the pulse width of 2 of the input pins. Just as if it was a model airplane servo reacting to servo, or model airplane receiver, model airplane throttle connected to a receiver acting like a servo. There we go. Again, AVR, Arduino, and compatible with all the AVR stuff. So let's go through here. It's sitting on this big honkin' heatsink. The whole thing is a heatsink with all of the necessary components being attached. Please note that 2 of the regulators have a plastic insulating dealie and plastic screws. Don't change that. Another thing I found is don't run these babies over about 21,000 hertz or the FETs all stay on at the same time and you fry them like I did. This, I'm also using the, not available in stores yet, but coming soon, this big honkin' on-off switch. And this is basically, there's a little toggle switch in here. And then right there and right there, a couple of big honkin' transistors. To turn on massive loads. In this case, to turn on the 30 amps plus available from this controller. This switch can be jumped, transistorized to get down to a TTL level. So basically, this on-off switch can be controlled by your main master controller. So your master controller can turn that on and off. Now, first of all, just if I could say balls, 15 amps per side, more with proper cooling. This whole controller is sort of designed for the Wild Thumper 6-wheeled vehicle, and it's designed for 7.2 volt packs. All of the instructions mention 7.2 volt packs. Now, it's capable of much more than that, up to 18 volts, but as your 5 volt regulator is turning extra volts into heat and burning off those extra volts, that we're turning into heat instead of currents. So You're not going to get the full amps you want out of this 5-volt onboard regulator as your voltage goes up. Pretty minor in my grand scheme of things. This 5-volt regulator for me is only running the Arduino and nothing external. Might be different for you. Oh, and there's screw terminals for your 5 volts out, power coming in, and motors going out, obviously. Right there, there's your little Atmega, or Atmel, or it's the 168, it's the Arduino 168 right there. And I gotta say, right off the bat, that is, it is phenomenal to be able to program the brain on the controller. It comes with software, it comes with code. It's very well documented, it's very well commented within the code to tell you what's what. It's very chunkable in terms of the way that's been written and commented. It's easy to remove the chunks that you want, remove the chunks you don't want, leave the chunks in you do want, modify, etc., etc. This is a blessing and a curse in that you can change it, but then you also have to change it. So if you are not someone who speaks Arduino or is prepared to reboot load with an ISP programmer to something else, then you're kind of stuck with it as working as a remote control servo, basically, in the pulse width mode. Even if you want to switch from into, say, serial mode, you are at least going to have to get into the Arduino code and change one value to do that. So you're going to need to speak a little Arduino, or just reboot load it to something else that you do speak and change it that way. That was no problem for me. I found it tremendously easy, and like I said, it was awesome. I actually stripped out quite a bit of the unneeded bits, and then I just did little stuff, like if you see there's extra cords here, those actually go up to that shift bright light, which casts a nice little circle of light on top of this. And for me, it fades, that little light fades from red to blue, or from blue to red, as my battery voltage goes down. So I can always, I just glance over here at the big spot of light and tell by the big spot of light if the condition of my battery. That's just one example. I mean, again, you have 7 I/O pins, digitals, and you've got 5 analogs all ready to go, plus your regular serial transmit and receive, plus USB. I don't know if I mentioned this. It's onboard USB with the FTDI chip on the bottom side, ready to go. So it's USB ready, USB friendly. I personally cannot say enough about this motor controller. Current sensing right on the controller, and able to talk to your robot brain and tell it what your motors are drawing. High current motor kill. I mean, basically, if you're drawing too much power, it will kill the motors and save your fuses. You know, monitoring voltage and knowing your batteries are getting low, and being able to tell your, main processor that, hey, your batteries are getting low. That's just ridiculously awesome. 15 amps per side, 30 amps total is per manufacturer's instructions, but wink wink, nudge nudge, with proper cooling you can probably squeeze a lot more out of this if you just bump up your fuses and keep an eye on the temp. I didn't say that, and I don't think the manufacturer is saying that, but you can do it. Onboard charger worked great. It was twice as fast as my regular charger. I've got it going to my 12 volt SLA. Bottom line, this right here, if you are driving... Oh, and I should mention, I am running DeWalt drill motors, so which when seized can pull in the 60 to 80 amp range. I'm actually finding now that I have current sensing and I can keep an eye on it, that when it's just driving around and not really under load, I'm actually only pulling about 8 amps or so. But But the bottom line, if you are running kind of the 3/4 size motors, not a giant robot, but bigger than most, in my case, Walter weighs about 25 kilos. And like I said, I'm pulling shy of 20 amps together. And so this controller has had absolutely no problem doing that whatsoever. So, bottom line for me, I would recommend this controller and this switch, available soon, to anybody wanting to run medium to larger size motors. And again, the only downside being that I can see, needing to speak a little Arduino if you want to do anything cool with it. Other than that, I will give this motor controller 2 full thumbs up. It is just one awesome controller for big motors. So, in conclusion, this has been Chris the Carpenter with Let'sMakeRobots.com reviewing the Daegu Wild Thumper controller. More information and a full review in text form at Let'sMakeRobots.com. Ting!